kids and adults and parents. Parents? Why would parents be here? Okay, hi mommy and daddy. Not sure why you're here, but I'm glad you're here with us too. Students, I'm glad you're here. Teachers, I would be here too. Just, all right, if I was you. No, I wouldn't. I'd be just heaven. I don't know what I'm talking about. Let's get started. By the way, if you want to find all of our information, it can be found at www.Newman, Krause, Infinity, because our videos go on forever and ever and ever. It's kind of like math class. If your math teacher's not quite so exciting and full of life and fun, it goes on forever. Or if you're just sitting in math class and you got the coolest math teacher ever, but the math is really, really hard. You're like, oh my God, is this pain ever going to end? All right, today's stuff's not bad. The good thing about statistics is, unfortunately, I say good thing and then I say unfortunately. And unfortunately is there's a lot of things to kind of memorize and get a hold of and get a grasp of and then keep track of. But understanding it's not at like a kind of a gut level. You can kind of understand what they're talking about, and some of it you're just not going to believe because you've been lied to your whole life about statistics and what they mean. But a lot of it you're going to understand. So we're going to get started on 8.2 notes. We're in Unit 8. By the way, if you haven't subscribed to the channel yet, you want to make sure you do so, especially when we start doing review stuff. You know, I'll post a lot of review up. You'll get notifications on any types of review that pop up. And you'll get when the videos are done and when the note sheets are ready to use, all that stuff. So make sure you subscribe. We're going to do measures of center and spread. Let's say this describes the center of the distribution. What describes the center of the distribution? Let's just talk about center for now. Center, mean. A lot of times we will use mean. By the way, you all know that mean is the average. Now, we could be talking about the average of the population, or we can be talking about the average of the sample. So if we're talking about the sample, the average, and I know I've said this to you before, we call X bar. Okay, that's X bar. All right, don't call it X liney thing, or don't call it X with a line over it. It's said X bar. You sound smarter when you say X bar. So if you're in class and you say X liney thing over it, and the rest of the class is looking at you funny, you'll know why, because it's X bar. If we're talking about the population, now remember, the sample is a small group randomly selected, hopefully, within the population. The population is everybody. Now, don't think the population means the entirety of the United States and you have to ask everybody. Remember, that's called a census. The population is whatever group that you're trying to get information about. If I want to come to your high school, let's say you're at a big high school in Syracuse, and I say, hey, I want to find out how all the kids in this Syracuse high school think about Twix or Snickers bars. I think they're made by the same company. I want to know what everybody likes. Well, I'm not going to, if I asked everybody, that would be the population, would be the entire high school in Syracuse. But normally I would just do a sample. But if we do ask the entire high school, we use a symbol called, this is the second time I've done this. It's called mu. Looks like a weird U, and it's mu. Mu stands for the population mean. And it's the average. Median is the middle number after the data has been sorted numerically. Well, let's say not numerically. Let's say in order. And it's this in order thing people always forget. You got to put the stuff in order, you know. If I say 5, 3, 7, well, the median's 5. But if you didn't order them, you might think, oh, the median's 3. Well, you got to put them in order. 3, 5, 7, and there it is. The median is 5. So don't forget, median has to be put in order. And by the way, this is probably one of the best measures of central tendency there is. Because it is resistant to mavericks or outliers. It is resistant to outliers. So the median is good because it is resistant. Is that an ENT or an ANT? Well, we're going to put both, and you pick whichever one you like. Resistant to outliers. And outliers we're going to talk about in a few minutes. We'll talk about what outliers are. But outliers are the kids that blow the class average. So if the entire class did really, really well and some kid got a 20, the average gets sucked down because of that kid. If the class did really, really crappy and then there's that one kid that's really smart, he got 100, then he skews the average up and it screws up that average. So those are outliers. But we'll talk about exactly how to define outliers in a few minutes. Mode is the most frequent value. Or in other words, another way to say it is that the value that occurs most often. The value that occurs most often. Not a great indicator of the center, because you could have data that went like this, 1, 1, 1, and then, and then have a billion other, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? This could be your data. I don't know what it is, but this could be your data. And you'd be like, oh, the measure of central tendency, the mode would be 1. And you'd be like, what? That's not even close to the middle. It should be somewhere over here, right? But because, you got 3 1s, I don't know what this represents, you're like, oh, that's got to be the middle, or it's a measure of central tendency. These are called measures of central tendency. And the mean, median, mode. And then there's the other one. Another measure of central tendency is also range, but we also call that the measures how spread out the data is. And the range is simple. It's defined as the difference between the highest value and the lowest value. I keep looking down my notes. So it's the max, or the X max, minus the X min. Now that isn't a great indicator as well. Let's say most of your data for your test was between 60 and 95, or 90, let's say. Well, let's say most of your, let's do it this way. Most of your scores were between 60 and 85, but you had this one person that got 100, and you got this one person that got a 20. Well, the range would be 80. By the way, it's just a number. It's not 100 minus 20. It's 80. The range is 80. It's a physical number. But if most of the numbers are here, and you got this way out here, and you got this way out here, then the range is very susceptible to outliers. The range does not account for outliers, which is why I have starred the IQR. The IQR is also resistant to outliers. So it is resistant to outliers. What is the IQR? This, first of all, it stands for interquartile range. You probably already know this from algebra. It is the middle 50% of the data. And it's defined as quartile 3 minus quartile 1. Once again, it's a number. Okay, if it's a number. So in this case, let's say this was your data up here. You had this 20, and then you had this 60 and 85, and these were your other two quartiles, and you're up here at 100. And so if these are your numbers, your interquartile, if this was 60 and this was 85, we'll talk about box plots in a few minutes. Your interquartile range, or your IQR, would be 85 minus 60, which would be 25. So 50% of your data is within 25 scores. This is another really important idea. We're going to spend a lot of time on standard deviation. It is defined as the typical distance from the mean. Now, when we're dealing with standard deviation, because you can have two different means, if we're talking about a sample, we use S of x. And that's for, this says this is the sample standard deviation. If we're talking about the population, now whenever we talk about the population, we get weird variables. So we're talking about this. It's actually, I like making it the way I like it. I was trying to make it the way it looks like this. It's this Greek letter sigma. So look up sigma, you'll figure out how to do it. Sigma, and this is for the population standard deviation. So when you're working with problems, you need to know, am I talking about a sample or am I talking about a population? And if they don't tell you if it's a sample or the population, you have to assume population. Just assume population. Now, the fact of the matter is 90% of the times, or 98% of the time, we deal with samples because nobody's got the money to collect for the entire population. But if they don't tell you it's a sample, then you have to assume that it's a population. Okay, children, here we go. My question is, what is standard deviation? And we're about to get some real math craziness on you right now. It is the square root of the sum of the square differences of each x from the mean divided by the number of values minus 1. What? Say what? By the way, if you wanted to do the population standard deviation, we would just get rid of this minus 1. So when you look on our calculator, when we go do this stuff on our calculator today, what you're going to see, and I should get that up, what you're going to see is the population standard deviation is always a little bit smaller than the sample standard deviation. And we'll talk about that eventually, why that's true. But when you divide by a bigger number, you know, if I get rid of this n minus 1, and I divide by just n, that actually makes it smaller. Think about this. If you had 10 divided by 5, that would be 2. But if I had 10, and just for fun's sakes, I'm going to go down so it makes my math easy. Well, here, let's do it this way. If I had 12 divided by 4, that would be 3. If I drop the denominator by 1 and I do 12 divided by 3, that would be 4, right? So when I subtract 1, I get a bigger number, and when I'm dividing. So that's a little bit of number theory. When you divide by a larger number, you get a smaller number, so on and so forth. So we'll talk about that in a minute. But what it is it's the square root. There's the square root. You've already talked about summations way back when. Summations. It's the sum of every x value. And this should be from x equals 1 to n, but we're not going to put that in there. Of all the x values minus the x bar squared. Now this is the sample standard deviation. And again, most of the time you use the sample standard deviation. Now in general, you're not going to have to do this calculation. You're not going to have to set this up. When I was young, we used to do like a page full of these things to figure it out. So let's say our x bar turned out to be 20. And then my data was like 21, 21, 23, 22, 19, 18. Well, this is, so you're going to subtract them. So if I subtract them, I get, 21 minus 20, that's 1. 1 squared is equal to 1. 21 minus 20 is 1 squared equals 1. 23 minus 20 is 3. 3 squared is equal to 9. 22 is minus 20 is 2. 2 squared is equal to 4. Blah, 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 so on and so forth. But what happens if I have an outlier? Now, this is why outliers cause problems, because part of the definition is you're going to square it. Let's say I had an outlier of 30. And I say, okay, 30 minus 20, that's 10. 10 squared is 100. Now, I'm going to add all these small numbers up, and then I got to add 100 to it. And then take the average of those. And you're like, whoa, when you have that 100 in there, that really... So outliers really, really, really affect the standard deviation. And again, we'll have another concrete example in class on how that's true, but just because of this squaring, it causes huge problems. The further you get away from the mean, it causes huge problems. We're not going to do that in this problem. We're just going to walk through a standard deviation. So in general, the calculator, we're going to use the calculator to find it, but I need to first find the average of these numbers. So let me add all these up. So I'm going to go to calculator mode. 2 plus 2 plus 4 plus 4 plus 5 plus 5 plus 7 plus 9. Hit enter. 1, 2, 3, 4, 5, 6, 7. Divided by 7. And I get... So one thing weird about this calculator, you really do want it to be always in fraction mode, but it's always frustrating when you hit it, you don't get the decimal you're looking for. All right, so we're going to use 5.14. So we're going to say our x bar is 5.14. So for each of these, we're going to subtract off 5.14. Let me do it a little bit smaller. So we're going to do 2 minus 5.14. That's equal to negative 3.14. We're going to do 4 minus 5.14, and that's equal to negative 1.14. And then we're going to do 4 minus 5.14, and that's equal to negative 1.14. You guys get it? 5 minus 5.14, that's equal to 0.14. 5 minus 5.14 is equal to 0.14. 5 minus 5.14 is equal to 0.14. No, this is 7. I just kept going. 7. 2.14. No. That's 1.86. And 9 minus 5.14 is equal to 3.86. All right, so now we have to square them. I don't know what these things are squared. I did the work, so we're going to take negative 3.14 and we're squaring. What's one property of squaring means it's always going to be positive. Now, if I square this, just so you know, I get 9.8596. 9.8596. If I square negative 1.14 and I square it, I get 1.2996. 1.2996. That means this one's going to be 1.2996. 0.14 squared is 0.0196. 0.0196. So this is going to be 0.0196. 1.86 squared is equal to, these are 0.14 squared. I should write these in. 0.14 squared. Actually, it's negative, isn't it? These are negative. And negative 1.14 squared. 1.86 squared is 3.596. And the last one is 3.86 squared is equal to 14.8996. 8996. All right. So these things that I just did right here, all of these, is this part. But this summation thing, this E, says you got to add them all up. So at the bottom here, I'm going to do the summation of all those. And if I add all those up, trying to save a little bit of time here on the video, if you add all those up, those are all positive, I get 30.8572. 8572. So now I'm going to use that in my calculation. So my standard deviation is equal to the square root of 30.8572 divided by, let's see how many numbers I got here. 1, 2, 3, 4, 5, 6, 7. 7 minus 1. And if I do this on my calculator, it's really 308572 all divided by 6. And I take the square root. I get 2.2. Well, let me see. I'm going to make sure this calculation's right. So I get the square root of 30 point, oops, 30, I'm having a hard time today, kids, 0.8572, 8572 divided by 6, 2.2667, yeah, that's what I have, 2.2677889. If I wanted to round this, let's say to the tens place, I'd say my standard deviation is 2.3. Now, just for fun though, let's say these were goals scored on your soccer team. Okay? Goals scored on your soccer team. And let's say, somebody got 9 goals. That's pretty good. You see, But let's say you have your superstar on your team, on your soccer team, and they scored 21 goals. They had 21 goals. Are they considered an outlier? Or let's see how that affects the standard deviation. So I would have to do 21 minus 5.14. So we'll do that on the calculator. 21 minus 5.14, enter, and I get 15.86. So the summation's not right anymore. So I would get 0.86. Now if I take 15.86 and I square it, I get 251.5396. Now when I add them up, plus 30.8572, I get 282. Now the summation is 282.3968. 3968. So now I'm going to come over and do the standard deviation again using that one person that we came up with. So now I'm going to take the square root of 282.396, and we're going to divide it by 8 minus 1. In this case, because now we have 8 people. So we're going to say S of x is equal to, and let's go over this, do this in our calculator. We're going to take the square root of fraction, 282.3968 all over 7. Isn't it 8 minus 1? It's 8 minus 1, 7. So now my standard deviation, I was going to say, wow, it's even less, but it should be a lot more. Oops. Forgot the... All right. So let's try this again. The square root of a fraction 282.3968 divided by 7. My new standard deviation is now 6.35. 6.35. It almost tripled the standard deviation. Now, standard deviation tells you how spread out the data. Does this data really look spread out? Not really. Not from 2 to 9 it doesn't. But when you add this 21 in, this outlier, do you see how it dramatically affected that standard deviation? So standard deviation is very, very affected by outliers. Okay, we'll be back. Well, that took a while. Anyway, I'm back. You're like, well, I didn't go anywhere. I know. I have to go do some video stuff. Okay, so the next question says, how many of the data values fall within, that within means above or below, one standard deviation of the mean. So we just take the mean, which was 5.14. And we're going to subtract off the standard deviation, which was 2.3, and we end up with 2.84. And if I take 5.14 and I add the standard deviation, I get 7.44. So how many of them are between? Now, you can't round, so I need it bigger than 2.84 or equal to 2.84 and less than 7.44. So let me highlight all the ones that are bigger than 2.44. Now I can't use 2, so this is bigger than 2. This one works, this one works, this one works, and this one works. So 5 of the scores. So the answer here is, why is that doing that? That's weird. So the answer is 5. 5 scores are within one standard deviation of the mean. How many of the data scores fall above or below 2 standard deviations? So in this case, I've got to do 5.14 minus 2 times 2.23. And in that case, I get 0.54. And if I do 5.14 plus 2 standard deviations, 2.3, I get 9.7. And so how many of them are between 0.5 and 9.74? And that would be all of them. All 7 are within 2 standard deviations of the mean. So we're not going to, like old school, ask you to do this by hand, but I really wanted you to see how it was created, how it was determined, because I want you to have a sense of how it's done. I don't want you to think, oh, poof, a miracle occurred and the calculator gave me a number and I have no idea where it came from. And now you also hopefully saw a little bit of how outliers affect the standard deviation. Now, you won't know what 2.3 and 6.35 really have to do with anything for a while, but eventually it'll sink in. You're like, wow, that's a big, big difference. So in order to do stat calculations, we're going to do it here on the gross domestic product, world gross domestic product, the GDP, for the last 10 years to determine median, range, interquartile range, standard deviation, and of this. So we got a lot of stuff to do on this one. So what we're going to do is we're going to use our calculator. And our calculator is pretty much going to give it all to us. To do so, we go into the spreadsheet. We're going to go into a spreadsheet. And we'll call this GDP. And we'll just start typing them in. 4.4, 4.3, 1.8. Negative 1.7, 4.3, 3.1, 2.5, 2.4, 2.6, and 2.5. So we got 10 years of GDP. So this is only one variable. It's one thing we're measuring. I don't care about the years and months. That's just for reference for later for our problems. So we'll go into menu. We're going to go into statistics. We're going to go into stat calculations. Now all these directions are in the color pictures above you so that when you're using your calculator at home, you know how to do it. We only have one variable, so we're going to do one variable statistic. We're going to be doing it on the, click on this and you click on GDP. And we click OK. All right, so it tells us that the X bar is 2.62. So X bar is 2.62. And it's right there. It even says X bar. See, it says X bar. Do you see where it says sum of the X's squared? Right? Isn't that some of the work that we did on the previous page? It'll also give you the population the sample and the population standard deviation. Notice the population one is a little bit smaller than the standard deviation, the sample standard deviation. That's because you use a bigger denominator. But in this case, because it's a sample, right here it says sample, it's highlighted right here, sample. We're going to use the 1.778. So instead round it to the nearest hundredth if necessary. So we will write 1.78. So my sample standard deviation is 1.78. All right, what else do they want? They want mean, they want median, they want range, they want interquartile range. All right, so let's do those. Let's go, I'll just write these down. Median, range, and IQR. I'm not going to write down interquartile range. All right, so the median, oh look, it says median right there. Median, 2.55. So the median is 2.55. Now remember, range is Q3 minus, range is max minus min. It's max minus min. So I come back over here. There's min, negative 1.17. There's max, 4.4. So I do 4.4 minus negative 1.17 or 1.7. And I get, I don't know, what is that, 6.1? 6.1. And then IQR is Q3 minus Q1. And that is going to be 4.3 minus 2.4, 4.3 minus 2.4, and that's what, 1.9? 1.9. All right, there's all the information they asked for, and they calculated it for us. Now, which would you prefer? Would you prefer to do it like this? How would you like to do it if you had 100 numbers, 1,000 numbers? No, the calculator do it in like 2 seconds for you. All right, how many GDPs fall within 2 standard deviations of the mean? So let's take the mean, which is 2.62, and we're going to add 2 times the standard deviation we found was 1.78. 1.78, and then we're going to 2.62 minus 2 times 1.78. And I don't have that calculation available. So we go over here, we go 2.62 minus 2 times 1.78. Negative 0.94. Negative 0.94. And then we're going to do the same calculation, but with a plus sign. I don't like retyping things. And 6.18. So how many fall between those two? So it's got to be bigger than this and less than this. Let's see. Let me highlight. Bigger. Yep. 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 Nope. Yep. 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 All but one of them. All but one of them fall within 2 standard deviations. It's just this weird one right here. I don't even know what that means. I guess it's negative growth. Terrible growth that year. Types of graphs. Below the 3 graphical representations of the data. It's example 1. Let's see if we can take a look at this graphical data. Refreshing. Anyway, let's get started. Let's keep going. All right, so I want to look at a dot plot. I'm on the wrong page. I want to look at a dot plot. And it should look something like this. I want to see how I can get this on a calculator. So this just, there's no intervals. Oops. No intervals. Why am I not going on to that? No intervals. No intervals. And you just stack them up. Just stack dots up. Now that doesn't look, well, that's okay, I guess. It's not bad. It's not great, but it's not bad. It could be better. It's this one that's causing the problem. It's an outlier. But let's see how to do that on a calculator. So to do that on a calculator, direction should be above. You do control, you make sure you have the cell highlighted. You're going to do control doc, data and statistics. And you get a bunch of stuff like that. And down at the bottom, you just click on this and you say, okay, I want to make this the GDP. Boom. Done. It makes a nice little dot plot for you. You can get an idea. You can say, oh, look at this one way out here. That's a problem. Let's say you don't want a dot plot. Let's say you want a histogram. So you just go into menu, plot type, and you choose histogram, and it magically turns it into a histogram, and you can see the bars and what they actually mean. Now, bars have actual interval lengths, and they'll pick what might be appropriate for you. And let's say you don't want a bar. Let's say you don't want a histogram. Let's say you'd prefer a box plot. So we'll just click on that, and it'll see that. Now, notice that you have this line going off here to the minimum and this line going off to the maximum, and there's a dot way out here. That dot way out there, whenever you have a dot that far away, that represents an outlier, and the calculator has already calculated for you that you have that outlier. All right, so a histogram, you have constant intervals. I keep losing my pen. Constant intervals of equal length, and the class's width. And these are really good. Where am I going? Good to see shape. Dot plots aren't bad, but histograms are much better. And these class width right here, these are called classes. They're all the same width. They have to be the same width. Box plots. This is the 5-number summary. We'll talk about that later. And you need to make sure you have a scale. Need scale. We'll talk about that as we do one of these. And this is good. Good to see center and spread. That's probably behind my head, so I probably should show that spread. Let me tell you what the 5-number summary is. You'll see 5 boxes up here. Let me just go through these real quick. This is the minimum. This is quartile 1. This is the median. This is quartile 3. And this top one is the max. And this is just an outlier because it's way out here. So 5-number sum. Min, quartile 1, median, quartile 3, and the maximum. And you'll notice, for the most part, it's pretty good data, except for this weird year over here. And what do you notice about the GDP in 2019? It doesn't seem to follow, it doesn't seem to follow the data. It seems to be, it's an outlier. It's an outlier. Does not seem to fit with all other data. And so an outlier, it's an abnormal point, you know that. But an outlier is defined, just so you know, an outlier is defined as the outlier is defined as the IQR. First thing you're going to do is take the IQR and you're going to multiply it by 1.5. And then you can determine if you have an outlier if you take the X bar and you add this IQR times 1.5, 1.5, and you subtract it, X bar minus the IQR times, oh wait, it's not the X bar, it's quartile 1 or quartile 3 plus the IQR and quartile 1 minus the IQR times 1.5. So I'll do one example of this, but an outlier is defined. First thing you do is take the IQR, the interquartile range, that center 50%, multiply it by 1.5, and then add it on to quartile 3, subtract it off to quartile 1, and anything that's outside of those two numbers are considered outliers, or too far away. They're abnormal numbers. So an outlier is an abnormal. An outlier is an abnormal data value. Abnormal data value. All right, so let's get started on this set of numbers. We'll get this into our calculator. We'll see how we're doing with it. Okay, example 2. Let's get started on that. We'll get this information into our calculator. We're not going to compute all this stuff. We're going to have the calculator do it for us. So we'll go over to the calculator. We'll type this in. Go to center. By the way, you see how you have all these tabs? That's a problem. You don't want to have all those tabs, so let's get rid of them. Choose Don't Save. Go back in, and you should have a nice 1.1 tab. You should be starting all over. So these are the number of Snapchats. So I'm going to call them Snap. Oh, Snap! Oh, man, I sounded so cool when I said that. Snap. All right, so 11, 17, 18, 10, 22, 23, 15, 17, 14, 13, 10, 12, 18, 18. So it looks like we have 14, 2 weeks. Yep, 2 weeks, 14. So we want to do, this is only one variable, so we put our box right here, and we're just going to go into menu, statistics, stat calculations, and one variable, statistics. You only have one list, and there will be a reason why you would want more than one list, but not today. Oh, snap! Man, dude, I am so cool. We'll snap that up, and we'll say, okay, our X bar is 15 point, what does it say? Round to the nearest hundred. So 15.57. So X bar is equal to 15.57. And what do we want next? Median. Let's just write these down. Median, sample. Wait, is this the sample? Didn't say sample, so when it says standard deviation, now I have to do the population standard deviation. Didn't say sample, so I'm going to do population standard deviation. And my interquartile range. Well, the sample standard deviation, the standard deviation is coming next. It's 3.994. Round to the hundreds place would be 3.99. The median and the next one, let's see, the median is 16. And the interquartile range is 18 minus 12, which is 6. Construct the dot plot. A dot plot is pretty simple. You just start putting dots. Now, you want to make sure that you have equal spacing between the dots. So my first dot would go right here at 1. For 11, and then 17 got a 1. And then 10, got a 1. And then 22 and then 23. Those were my big snapping days. And then 15. And then 17 again. So I put a nice equal spacing. Now, you're not going to have these lines necessarily. You just have to make sure you create equal spacing with your dots. Otherwise, it's inaccurate. You got a 14. Because you want to be able to get a picture of what's going on. Another 10. Another 12. And then 2 18s at the end. Wait, I should already have an 18. I must have missed that 18 to begin with. There are 3 18s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I just missed that 18 to begin with. So there are 3 18s. You should get a picture on what's going on. The mode is 18. The middle appears to be, somewhere right here in the middle, somewhere around 16. Simple dot plot. So let's construct a box plot. Now, in order to do a box plot, first of all, you have to have a scale, and you need the 5-number summary. The 5-number summary is the min, the quartile 1, median, quartile 3, and the maximum. And we have all that stuff right there. Let's see. It's right here. There's the 5-number summary. 10, 12, 16, 10, 12, 16, 18, 23, 18, 23. It's beautiful. There it is, right there. Now, I need to have a scale. It's not okay just to draw a box plot. You have to have a scale. So we're going to go from 10 to 22. So let me see. That's a total of 13. Do I have 13 lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have plenty. So I'm going to start here. 10, 12, 14, 16, 18, 20, 22, 24. So my minimum was 10, so I'll put a dot here just for the minimum. My Q1 was 12, so what I have to do here is I want to put a line right at 12. My Q3 was 18. I'll put a line right here at 18. And that makes my box for my box plot. I skipped median on purpose. Median was 16. That goes here. And my maximum was 23, so that goes here. I draw a whisker. Sometimes they call it box and whisker plot. Most of the time, just called box plot. All right, and what do each one of these represent? You should know this from 9th grade. This represents 25% of the data. This represents 25% of the data. This represents 25% of the data. And this all represents 25% of the data. There it is. Last problem of the day. Fitness Blender is a website that thousands of workout videos. It has thousands of workout videos. And if you know Miss Newman's kind of a crazy fitness freak. She loves this website. She can't get out and run. She's in her room or at home doing these strange workouts. Below is a list of her workout durations in minutes over the last month. So 2, 4, 6, 8, 10, whatever. We're going to put these in. Now, anytime I see data like this, the first thing I think of is the kids are going to make a mistake because there's lots of data points here and they're going to make a mistake. So be careful getting these into your calculator. Remember, you already have a list in here. If I was to go in and click on this, I already have 2 spreadsheets. I don't want 2 spreadsheets. You always click the X, choose no, go back in. Make sure you're always working in 1.1. Otherwise, your data can get mixed up. All right, it's a mess. So be descriptive. This is minutes. Oh, you can't use min because it stands for minimum. So minutes, UTS. We're okay with minutes. So now we're going to put these minutes in. Since I don't want to have to keep going back and forth, I'm going to read them off my paper. 31.27. If you want to fast forward, this would be a good time to fast forward. 25.95, 27.13, 24.53. I'm going to pause. I'll be right back. So I got those all typed in, and as I was typing them in, I think, is Newman crazy? Like, who measures their minutes worked out to the hundreds? Okay, cuckoo. But there should have been 20 numbers. I got 20 numbers in. Hopefully I got them in right. Hopefully there's not any crazy numbers that I typed in accidentally wrong. So we are going to do, it's one variable, so we're going to do one variable statistics. So we'll go menu, statistics, stat calculations. We're going to do it on our minutes, and we click OK. Oh. Can't cancel. I clicked on the wrong thing. Menu, stat calculations, one variable statistics. Click OK. Do it on our minutes and click OK. All right, so there is our information. Now, I'm not sure what we asked. Oh, it said construct a histogram. Oh, my goodness. All right, so let me go over here. We're going to construct a histogram. So let me highlight all the ones between 24.1 and 34. 24.1 and 34. $34. 24.1 and 34. That's a lot. 24.1 and 34. All right, so all of those. So if I was to create a histogram, I need a bar chart. Notice my classes, again, these are my classes down here, are all the same length. So 24.1, and then we'll just have this as our frequency. 1, 2, 3, 4, 5, 6, and I should have put those on there already for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oops. Let's see, 2, 4, 6, 8, 10, 12. So every one of these is going to be 4. Let's make them 4. 4, 8, 12, 16, and 20. So every one of them is 4. So my first bar is going to go up to 14. Boom, 14. That's 14. 14. All right, so my next bar is between 34 and 44. 34 and 44. 34 and 44. 34 and 44. 2. So that's going to go 2. 44 and 54. 2. Did I miss one? Oh, wait. 44 to 54. 3. And I'm not going to have any until I have this 1 down here. Okay. All right. So that would be my histogram. Notice the bars touch each other. It's Miss Newman's workouts. All these classes are all the same down here. Not the greatest data collected, because we got this bar that's over here. It's called skew to the right. We'll talk about skewness as we talk about distributions later on. But let's say I create a box plot. Remember, for a box plot, I need 3 things. I need 5 things. I need the min. I need quartile 1. I need the median. I need quartile 3. And I need the max. Go over to calculator, scroll down, ding, 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 ding. 24 point, the minimum is 24.53, 24.53. Quartile 1 is 26.135. The median is 27.13. Quartile 3 is 34.9. And the maximum is 83.93. So I need to get from 24 to 84, basically. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's say there's 20 of these. 20 times 2 would be 40. That's not enough. 20 times 4. We're going to have to make every one of these 4, it looks like. I'll make every one of them 3. So let's make this 24. I think that'll work. 24. Why is it every time I make a 4, it doesn't come out right? 24. That would make this 27. That would make this 30, 36. I think I'll get there if I do this. 42, 48, 54, 60, 66, 72, 78, 84. Yep, got it perfectly. Okay, so minimum was 24.53. That's somewhere down here, dot. The maximum will be down over here somewhere around 84. Quartile 3 is 26.1, so 26.1 would be, let's see, that's 27, so that's right here. 34.9, or right around 35, that's going to be somewhere around here, would be quartile 3. There's my box. And 27.13 would be my... So what do you think about this thing out here? What do you think this thing is? Yeah, it's an outlier. And if that's an outlier, then this is not an appropriate graph for a box plot. You have to change what it looks like. And we don't want this to be our box plot. So yes, you're going to use the 5-number summary unless we have outliers. So how do you determine an outlier? Well, you take, first of all, we need the standard deviation. And the standard deviation was, and this was not a sample, this was a population. So we're going to take the standard deviation, which is 14.2. We'll just use 14.2. 14.22. And we need the IQR. So this is our population standard deviation. And we need the IQR. And the IQR is 34.9. 34.9 minus 26.23. 26.23. 8.67. 8.67. And we're going to multiply that. So remember, it's Q1 minus the IQR times 1.5. And Q1, Q3 plus the IQR times 1.5. So I'm just going to do that in my calculator. So my calculator, I'm going to come over here and I'm going to say, okay, 26.23, that's quartile 1, minus 8.67 times 1.5. $13.2. 13.23. And then I'm going to take 34.9 and I'm going to add 8.67 times 1.5. And I get 47.9. And I get 47.905. So everything outside of those are outliers. Anything above 47.9 is an outlier. Well, I believe that gives me 2 outliers. That gives me this one's an outlier and this one is an outlier. So then my maximum would be whatever the one that's closest to those without going over. In this case, it's 49.83. So we're going to use the 49.83. By the way, I'm sorry about this. I didn't go back and fix this. This was 2. This was 3. All right, because we had the extra one right here. But there's this has an outlier, and actually that 52.22 is an outlier. So really my top point should be at 49.83. 49.83. So somewhere around here. This would be my box and whisker plot. Now, in order to represent outliers, we just put a dot. So you'll keep this dot here. And what's my other dot? My other dot was 52.2. So my other dot was, let's see, that's 48, that's 51, so 52. So I have another outlier right here. Now you can also see this, and you'll know your dot plot if you go here and you say, okay, let's see, how did you do that again? Control division. Oh, no, we got to go back to our thing here. Highlight a cell. I'm going to highlight this cell. We're going to do Control Doc, Data and Statistics, right? We're going to call this minutes. And then we're going to say, okay, menu, let's change the box type to a box plot. And notice what happened. Oh, this bar is missing. This stripe's missing here. But it says that's an outlier and that's an outlier. So this number right here should be 4.83. The line's missing. I don't know why the line's not there. Usually shows up. The line should be going to this 49.83, but these two would be outliers. And that's how it works. All right, kids, I'm done. Catch you on the flip side. Goodbye. Hit subscribe. Hit the like button. Give me a comment. Tell me how awesome this video was. Bye.